When we first learn about light, we're taught a very comforting story. Light leaves a source, travels in a straight line, and arrives at its destination. Simple, clean, predictable. It fits perfectly with how we expect the world to behave. And for everyday life, that story works well enough. But Feynman loved pointing out that when a story works too well, that's usually a sign it's hiding something important. You really ask light what it's doing between here and there, it gives an answer that feels almost insulting to common sense. It doesn't take one path. It doesn't even take a few reasonable paths, according to the mathematics that actually predicts experiments correctly. Light behaves as if it explores every possible path it could take. Not just the straight line, but paths that loop around, wander off, hesitate, even paths that seem utterly ridiculous. And yet, somehow, out of all that apparent madness, we consistently observe light arriving as if it chose the most efficient route. Feynman's brilliance was in refusing to smooth this over with comforting language. He didn't say light might be confused or that this is just a metaphor. He showed that if you calculate the contribution of every possible path, assigning each one a tiny rotating arrow of probability amplitude, you get the right answer. The straight line path isn't chosen because light prefers it. It survives because all the nearby paths reinforce one another, while the wildly different ones cancel out. The straight line emerges not as a decision, but as a consequence. There's something deeply unsettling and deeply beautiful about that. We like to imagine the universe as making clear choices the way a person does, but light doesn't deliberate. It doesn't hesitate. It doesn't weigh options. It simply obeys a set of rules so consistent that order appears automatically. The path we see is not the path taken. It's the path that remains after all other possibilities have argued themselves in silence. Psychologically, this should make us uncomfortable, because we tend to project intention onto everything. We ask, which path did it really take? And Feynman's answer essentially is, that question doesn't mean what you think it means. Reality at this level isn't obligated to give you a single narrative you can visualize. It only has to give you results that agree with experiment. The discomfort you feel isn't a flaw in physics. It's a flaw in intuition shaped by a macroscopic world. Philosophically, this idea cuts even deeper. If light reaches its destination by a process that involves every possibility, then the straight line is not fundamental. Efficiency is not chosen. It is revealed. The universe doesn't aim for simplicity. It filters complexity, until simplicity is all that's left. That's a very different worldview from the one we instinctively carry, where outcomes are the result of deliberate causes march neatly forward in time. Feynman often emphasized that understanding doesn't always mean being able to picture something. You can understand light perfectly and still fail to imagine how it really moves. In fact, insisting on a mental picture can block understanding entirely. The genius move is to accept that nature's logic may be alien, yet astonishingly precise. When you let go of the demand for familiar explanations, the equations stop looking mysterious and start looking honest. And here's the quiet lesson hidden inside all of this. Progress, whether in science or in thought, often comes from allowing many possibilities to exist at once, long enough for the wrong ones to cancel themselves out. Certainty too early is the enemy of truth, so the next time you see a beam of light moving effortlessly across a room, remember this. What looks simple is often the residue of unimaginable complexity, and the straightest path in life, like in physics, may not be chosen. It may be what remains when everything else falls away. Once you accept that light doesn't behave like a tiny bullet flying cleanly through space, the next strange thing follows almost immediately. Light does not experience time the way we do. This is where Feynman would usually slow down, smile a little, and warn you that your intuition is about to betray you again. From our perspective, light clearly takes time to travel. We can measure it. We can slow it down in materials, bounce it off mirrors, delay it in fibers. But from the perspective of the light itself, if that phrase even makes sense, there is no passage of time at all. The instant it is emitted is the same instant it is absorbed. Zero time passes. Not a very small time. No time. This isn't poetry. It drops straight out of Einstein's relativity. And Feynman loved how brutally simple the conclusion is once you accept the premise. Anything that moves at the speed of light experiences no proper time. The clock moving with the light simply doesn't tick. And that forces us into an uncomfortable realization. Time is not a universal backdrop against which everything unfolds. It's conditional. It depends on how you move through space. Psychologically, This is deeply disturbing, because we build our entire sense of self around continuity through time. Memory, identity, cause, and effect, all of it assumes that time flows steadily and equally for everyone and everything. But light violates that assumption completely. The universe allows entities for which the journey has no duration at all. Distance exists. Change exists. But time, for them, does not. Feynman would often emphasize that this is just a technical detail. It's a clue about how reality is stitched together. We talk about space and time as separate things because that's how our brains evolved to function. But nature doesn't care about our categories. To the universe, space and time are fused, and what you experience depends on how you move through that combined structure. Light sits at the boundary where our familiar notions simply stop working. Now here's where it connects back to how light actually travels. When we say light explores all possible paths, those paths are not just spatial alternatives, they are space-time histories. Each possible route corresponds to a different way of slicing up space and time together. The reason certain paths reinforce each other isn't because they're shorter in distance, but because they're stationary in action. Nature isn't minimizing distance or time in the everyday sense, it's balancing the structure of space-time itself. This is why interference patterns exist at all. Light doesn't interfere because it's confused or indecisive. It interferes because different histories can overlap in a way that either amplifies or erases outcomes. Time, in this picture, is not a flowing river, but a dimension that participates in the calculation. When you watch light create bright and dark fringes on a screen, you're watching space-time. Possibilities negotiate with each other. Philosophically, this forces a radical shift. If light doesn't experience time, then before and after are not fundamental properties of reality. They are properties of observers like us, slow, massive, deeply embedded in time. The universe is not obligated to privilege our experience. It simply allows it. Feynman never pretended this was comfortable. He would say, quite openly, that nobody really understands this in the sense of being able to visualize it cleanly. But understanding, to him, wasn't about comfort. It was about accepting what the equations and experiments are relentlessly telling us, even when they undermine our most shed intuitions. And here's the quiet challenge hidden in all of this. If reality itself is not built around a single, universal flow of time, then clinging too tightly to fixed narratives about the past, the future, or even yourself may be a misunderstanding, not a virtue. Light moves without experiencing time. Yet it shapes everything we see. Perhaps the deepest progress, like light's journey, comes not from rushing forward, but from realizing that the moment you're in may be far less solid and far more powerful than you. We've been taught to believe. Up to this point, we've been talking as if light is doing something definite while it travels exploring paths, canceling possibilities, reinforcing others. But here's where Feynman would deliberately pull the rug out from under us. Until light interacts with something, it isn't doing any one thing at all. It's not hiding a secret path we just haven't discovered yet. The path itself is not a fact of reality until an interaction forces it to become one. This is where the human mind really starts to resist. We are wired to believe that the world has definite properties independent of us. A particle must be somewhere. A wave must be spread out. A journey must have happened in one specific way. But light refuses to cooperate with that worldview. When you don't measure which path light takes, the universe behaves as if it took all of them. When you do measure, the other possibilities don't just become hidden, they disappear. Feynman W. is very clear about this. It's not that the act of measurement disturbs light in a mechanical sense, like bumping into it. Measurement changes the conditions of reality. It changes what questions nature is allowed to answer. Asking which path did the light take is not a passive request for information. It's an intervention that reshapes the outcome. Psychologically, this is unsettling because it places the observer inside the story, not outside it. We like to imagine ourselves as neutral spectators watching the universe unfold. But at the quantum level, there is no such thing as a detached observer. The moment you demand certainty, you sacrifice interference. The moment you allow ambiguity, you gain pattern and structure. You can't have both. What's crucial and often misunderstood is that this has nothing to do with consciousness in a mystical sense. Feynman had no patience for vague claims about the mind creating reality. A detector, a screen, a piece of matter is enough. The universe doesn't care who observes. It only cares that an interaction capable of distinguishing alternatives has occurred. Reality crystallizes not because a human looked, but because information became irreversible. And this leads to a deeper philosophical implication. Facts are not always waiting in advance. Some facts only come into existence when the universe is forced to choose. Before that, there are only probabilities, structured, lawful, mathematically precise probabilities, but not outsea. Ohms. The past itself, at the microscopic level, can be less definite than we imagine. This collides head-on with our sense of causality. We think causes precede effects in a clean chain. But light doesn't commit to a single history until the very end. The final interaction reaches backward, in a sense, and selects which histories were allowed to matter. Not by rewriting the past, but by revealing that the past was never singular to begin with. Feynman loved pointing out that this isn't a failure of physics, it's a failure of intuition. The equations work perfectly. The predictions are stunningly accurate. What breaks down is our demand that reality behave like a classical story with a single plotline. Nature is more economical than that. It keeps its options open until it can't anymore. Now pause and notice how this mirrors our inner lives. We often treat our own past as fixed, as if every choice was inevitable, every outcome already written. But in many cases, the meaning of past events only solidifies when something later forces us to interpret them. Until then, multiple narratives coexist. The mind, like nature, resolves ambiguity only when it must. This doesn't make reality weak or vague. It makes it flexible and profoundly creative. The universe is not a rigid machine grinding forward from a predetermined script. It is a system that allows possibility to breathe right up until the moment of decision. And here's the quiet takeaway Feynman leaves us with, whether he says it explicitly or not. If the universe itself does not insist on certainty until the last possible moment, maybe we shouldn't either. Understanding doesn't come from forcing answers. Too early it comes from learning how long you can let the question remain open. Now let's push this one step further, because this is where Feynman really changes how you think about explanation itself. When people first hear that light takes all possible paths, the immediate reaction is to imagine a mess light, spraying everywhere, wasting effort, behaving inefficiently. But that reaction comes from a very human bias. We think nature should be economical in the way we are economical. Feynman shows that nature is economical in a much deeper, almost alien way. Light doesn't choose the shortest path because it knows it's the best. It doesn't evaluate options and then decide. Instead, every possible path contributes a tiny influence, and most of those influences cancel each other out. Only near a certain kind of path, the one we later call the path of least time or least action, do the contributions reinforce instead of self-destruct. What survives is not chosen, it emerges. That's a profound shift. The classical explanation says, light travels straight because that's the rule. Feynman's explanation says straightness is what remains after all the nonsense eliminates itself. Psychologically, this matters because it attacks our instinct to believe that order must be imposed from above. We're trained to look for a controlling principle, a master rule that tells reality what to do. But here, order arises from interference. Stability comes from cancellation. What looks purposeful is actually the residue of countless failed possibilities. This is uncomfortable because it undermines the idea that understanding means reducing things to a single cause. In Feynman's picture, understanding means accepting a swarm of causes and knowing why most of them don't matter. The universe doesn't simplify things for our convenience. It allows complexity, then lets mathematics show us why only certain patterns survive. And notice something subtle here, the best path is not privileged in advance. It becomes privileged only because nearby alternatives agree with it. The moment that agreement breaks down, the pattern dissolves. This means that reality, at its core, is not built from certainty but from coherence. What exists is what can stay in step with its neighbors. There's a philosophical echo here that's hard to ignore. In life, we often search for the single correct path, the right decision, the optimal plan, the one true explanation. But Feynman's physics suggests something more nuanced. What works is often what many possibilities support simultaneously. What fails is what can't maintain coherence when tested from multiple directions. Feynman didn't romanticize this. He didn't say it was beautiful to comfort us. He said it because it's true, and because refusing to accept it blocks real understanding. The moment you insist that nature must behave in a simple, story-like way, you stop learning. You replace curiosity with demand. And here's the real twist. This framework doesn't just explain light. It reshapes what we mean by why. When you ask why light goes from here to there in a straight line, the answer is not because it wants to or because it must. The answer is because every other possibility destroys itself. That's a very different kind of explanation. It doesn't appeal to intention or authority. It appeals to inevitability born from structure. The rules don't command outcomes. They allow outcomes to survive. Feynman wanted people to feel the shock of this, not smooth it over. He knew that once you accept this way of thinking, you can't unsee it. You start noticing it everywhere in physics, in evolution, in ideas, even in personal growth. What lasts is not what is declared correct, but what remains consistent under many pressures. So when light travels, nothing mystical is happening. And yet, something deeply unsettling is revealed. Reality is not built by choosing the right path. It is built by allowing all paths and letting interference decide. What endures, if you take that seriously, it changes how you think, how you question, and how patiently you let ideas collide before you commit to an answer. Because progress, whether in physics or in thought, comes not from forcing certainty, but from letting weak ideas cancel until only the strongest pattern remain. Now, there's another layer to this story that people often miss, and it's where Feynman becomes almost mischievous. Once you accept that light explores every possible path and that what we observe is the result of interference, you might think the mystery is over. But it isn't, because the moment you ask how we know which pattern survives, you're forced to confront the role of measurement, description, and limits of human intuition. Feynman was very careful here. He didn't say that light behaves strangely because it's small or because our instruments are crude. He said it behaves strangely because reality itself doesn't care. How our minds evolved to make sense of the world. Our brains are tuned for throwing rocks and catching prey, not for tracking probability amplitude. When we talk about light, we don't talk about little bullets flying through space. We talk about arrows, phases, rotations, mathematical objects that don't resemble anything you can touch. And that's not a failure of language, it's a warning. The universe is under no obligation to be picturable. This is where the psychological discomfort really sets in. We want explanations to feel solid. We want them to click like a lock turning. But Feynman showed that some explanations only work if you stop demanding a picture and start accepting a process. Light doesn't look like anything while it's traveling. It only produces outcomes when interactions happen. And this leads to a deeply unsettling idea between emission and detection. Light is not a thing in the way we normally mean things. It's a set of possibilities governed by strict rules, not a tiny object following a story-like journey. The rules are precise, but the narrative is missing. Feynman never tried to soften this. In fact, he leaned into it. He famously said that if you think you understand quantum mechanics, you don't understand quantum mechanics. Not because it's vague, but because it's exact in a way that clashes with human instinct. Philosophically, this forces humility. It tells us that understanding does not mean comfort. Understanding means being able to predict outcomes accurately, even if the mental picture feels incomplete. Nature is not confused, we are, and there's something strangely liberating about that. Once you stop demanding that reality behave intuitively, you're free to learn from it instead of arguing with it. You stop asking, why is it so weird? And start asking, what are the rules and what do they allow? This has consequences far beyond physics. We often confuse explanation with familiarity. We think that if something feels strange, it must be wrong or unfinished. Feynman flipped the idea upside down. He showed that strangeness can be the signature of truth operating outside our evolutionary comfort zone. Light doesn't slow down to make sense to us. It doesn't choose paths to satisfy our logic. It obeys mathematical principles that work perfectly, even when they offend our intuition. And the only reason we can predict its behavior at all is because those principles are consistent, not because they're easy to imagine. Feynman's deeper lesson is this: reality is not built to be visualized but to be discovered. The demand that everything make common sense is not scientific rigor, it's intellectual laziness, dressed up as skepticism. Once you accept that, something changes in how you think. You become more patient with ideas that feel incomplete. You stop rejecting concepts just because they don't fit your mental furniture. You learn to let mathematics, evidence, and experiment guide you, even when your imagination struggles to keep up. Light teaches us this lesson every time it moves. It behaves in a way that is precise, repeatable, and utterly indifferent to human expectations. And if you take that seriously, you're left with a powerful challenge. Stop demanding that truth feel comfortable and start training your mind to follow it wherever it leads. By the time we reach this final idea, something important should already feel unsettled in your thinking. Because if light does not travel the way common sense insists, then the problem isn't light. The problem is the way we've been trained to think about reality itself. And this is where Feynman's deepest insight quietly lands, not as a formula, but as a mental discipline. Feynman understood that the danger in science is not ignorance, it's premature certainty. We build intuitive stories too early, and then defend them as if they were facts. With light, those stories collapse. The particle story fails. The wave story fails. Even the hybrid story only works if you stop asking it to behave like anything familiar. What survives is not a picture, but a rulebook. Light follows rules with astonishing precision, but it refuses to be visualized in a single, comfortable way. And Feynman would say, good. That resistance is not a flaw in the theory. It's evidence that you've reached the edge of what human intuition evolved to handle. Here's the psychological shift he was inviting us to make. Stop asking, what is light really doing? And start asking, what must be true for the predictions to work every time? That move sounds subtle, but it's revolutionary. It replaces the need for mental imagery with respect for structure. You don't need to see the process. You need to trust the consistency of the rules. This is why Feynman insisted on calculation over comfort. He didn't dismiss intuition, he disciplined it. He taught that intuition must be trained by reality, not the other way around. If your intuition disagrees with experiment, intuition loses every time. And once you accept that, light becomes a teacher rather than a puzzle. It teaches you that the universe is not obligated to explain itself in stories. Stories are for humans. Nature speaks in patterns, probabilities, and constraints. There's also a quiet philosophical implication here that's easy to miss. If light only produces definite outcomes when interactions occur, then certainty itself is not fundamental, it's emergent. Reality, at its core, is not a set of fixed objects moving along paths. It's a web of potentialities constantly resolving into events. That idea should make you pause, because it extends far beyond physics. How many times in life do we demand certainty before action? How often do we reject ideas because they don't fit a neat narrative? Feynman's lesson is that waiting for perfect clarity is a mistake. Progress comes from working with incomplete pictures, as long as the rules are sound. Light doesn't wait for us to understand it. It doesn't slow down to become intuitive. It doesn't choose a simpler explanation because we prefer one. It moves according to principles that are exact, indifferent, and astonishingly successful. And the most radical part is this: we can build lasers, computers, satellites, and entire technologies on rules we cannot fully picture. Understanding, in the scientific sense, does not mean mental comfort. It means reliability. Feynman wanted people to feel this tension, not resolve it too quickly. He wanted you to sit with the discomfort long enough to grow, because the moment you stop insisting that reality must make sense your way, you become capable of learning what it actually is. Light, in that sense, is a test. It asks whether you are willing to let go of familiar thinking in exchange for deeper truth. It asks whether you value explanation that feels good or explanation that works. And here's the final challenge Feynman leaves us with. Don't aim to make the universe simpler, aim to make your mind more flexible. Because the world is not strange. Our expectations are.